Hello everyone, welcome to our channel. In this video, we are going to learn about Pydantic, which is a data validation library in Python. Most of the popular library and packages and framework you heard like LangChain, FastAPI, etc. are using Pydantic under the hood. So let's understand all the features of Pydantic in this crash course. Let's go back to the VS Code. Let me walk you to all of the feature quickly and then run that program with the help of UV command. Okay. So what Pydantic gives us? It gives us capability of validation, data validation at runtime, because compile time we already seen using type hints, etc. But that are not very sufficient enough. If the data coming from external sources have invalid data, then it will be a problem. Okay, so we want to prevent that kind of problem, because if you look into this in AI world, you create application, most of the things that you are getting from the LLM, and the LLM may provide you the invalid data or incorrect data, and there the Pydantic shines. You can apply the Pydantic and do the data validation at that point. Okay, so first of the core feature is validation. Second is serialization, data serialization, conversion of object to JSON or different formats which goes over the network, and deserialization as well, obviously. And then JSON schema, which is OpenAI documentation we can generate from Pydantic schema. And third is we can also do custom validation. We can apply the custom validation as well. Okay, so let's understand validation first. I've created a small program over here. So before going forward, let me talk about the repo. This particular repo is public and it is set up with the help of UV init command. And I'm going to run the program with the help of UV run command. Okay. So let's understand this validation.py program. Here I'm using the debug function to print anything over the terminal so that it is pretty much good to show you and make you understand everything over the terminal instead of using print. So for that I'm using the DevTools package using the UV add command. You will find it in the readme file, what are the things that I am using and how I have installed it with the help of UV add command. Okay, let's go back to validation.py. So what is the problem that we have to use Pydantic, and what extra features apart from validation it provides? So this is a very basic example. Normally when you create a class, you create a class like class user or any other class and then introduce the attributes. Okay, so here in this case I'm showing up this class id name and then object of this class user and id and name parameter and trying to debug it. Now as you know that when you create a class in Python, you must have a constructor underscore init underscore, and that is responsible for taking up this parameter, right? So here I'm just showing you that if I pass this, it will give us an error. Okay, usually it will give error. Okay, UV run src. Let me run this program. Validation.py. Okay, it is an error. Everybody knows, right? Now let us go one step ahead. To solve this error, what you normally do? You introduce init function, right? You introduce init function and run the program. You introduce this init function, it will run. Let me save it. Now it is running correctly, right? Now if you look into this, id is int of type int, basically it takes number, and name should take string. So this is a type hint. Basically it's associating a data type to variable. It's a type hint in Python. Okay, so here you are passing 11, although in a string, right? But what it is not complaining me anything. Even if I'm typing in here, it does not complain. But yeah, it may complain if you obviously make use of the VS Code extension, etc. But ultimately it will work if you put in, because these values are in your hand. Like currently you are setting these values, but in production, when the things are working, these values are coming from different functions or any third party call, etc. So that may be a problem, because that time this particular types do not prevent you, or do not prevent the program to actually pass. Okay, if I'm running this program, it runs. Even if I'm passing a as well, it will let me show you, it still runs, right? Even if I'm passing a to a integer, it still runs. Now where does the Pydantic shines? Let me comment this block quickly. Now here is the use of Pydantic. I hope my screen is visible. I'm doing to and fro too much. Let me just scroll down and clear this screen as well. Okay, now here, in order to use the Pydantic, what you need to do? You need to have a package of Pydantic installed using UV. Secondly, you need to take up this base model and validation error from Pydantic package. Okay. Now what happened? Whatever class you create, okay, you need to pass this as a base model. It basically kind of an inheritance, okay, where you need to pass this base model in the bracket. So what two thing it does? It gives the capability of providing the validation rules. Okay. Secondly, it do not we do not need to create init function. It automatically creates that for you and supplies to us. So here we are not supplying any init function, but still it will work. Secondly, if you need to control how the init function gets generated from this base model, you can also do this with the help of Pydantic configuration as well. So this is just for illustration purpose that I'm not showing here that configuration. So now if I run this program, it will run and like the way the above program runs. Now it runs and now I'm printing this with the debug statement user. It's showing me, okay, ID 11 and name Arjun. Okay. Now in this case, let us see the validation error example. Okay. I'm providing the correct value over here. Okay. So even if I'm passing this 11, it works. Okay. What happens is that Pydantic works in two mode, Lex mode and strict mode. By default, Pydantic has a Lex mode. So Lex mode means even if it is a string, numeric string, it converts into the numeric value automatically. So it does not complain. But if you run it with strict mode, then it will complain. We will see in the strict mode example, okay, shortly. So let me just comment this and show you the exact error case. Now this is the error case. Let me uncomment this section. Now this is the error case example. Okay. Now what this example is, simply same, everything is same. Now what it says, instead of directly initializing with the constructor, I am taking a JSON data. Assume that this JSON data is coming from external world, maybe from an API call, etc., which is the real case in production. So it is going to happen, right? Instead of having the value hard coded, you might get value from the backend systems or downstream system. So if the downstream system is giving incorrect value, incorrect type, then it should fail. Now let us see whether it fails or not. Here I am supplying 1, so it should succeed because here it automatically does the conversion. Here I am using the try except statement block. In case of an exception, this block shows the error. Okay, so let us run this program. Now it runs, there is no complaint. It do the model dump. Basically it has a function model dump. With the help of model dump, it converts that object into the JSON. So we can do this with the help of model dump function. Okay, provided by Pydantic itself. Okay. Now let us bring in the error. If I am typing in A instead of 1, which is not a number, right? It cannot do the conversion. Now in this case, the exception happen. It will print the errors. Let me run the program again. Now it shows the error. Okay. So here it shows the error. Type int parsing. Input should be a valid integer. Input A and the URL where it takes up the Pydantic schema, etc. Okay. So in this way, you see the beauty of Pydantic. If the data coming from the external world, maybe from the AI, from the LLM, etc., it's not correct type, then it will fail and show us the error. This is the one core feature of Pydantic, which is easier to apply. We just have to put in the base model in whatever class we create, and we do not have to use the init, and we just have to add this except block in our logic, and then it will show the error whenever it happens. Okay. Now let us see. We will also understand what all types the Pydantic supplies and what extra validation rules we can apply. Maybe we have an extra rule that ID should not be maximum digits within ID should not be more than 10, etc. And the name should not exceed maximum length, etc. So everything we can do with the help of Pydantic. Okay. So let us take the second example, which is on the constraints. Now, which is just I was talking about. I'm just clearing up the screen. Now in this example, what we did the same thing, base model. Now in typing extension, basically we have the attribute annotated, right? Now this we have seen in the type hints video in the last video, right? How to use this annotated. What annotated does, the same thing, like instead of using id colon int, so we can simply write in annotated int comma. Here we can supply the metadata. Okay, so what Pydantic team does, they makes use of this feature of annotated. So in the metadata, they have come up with a type field. Okay, they have come up with a type field. So this we can supply as part of second argument of this annotated, and then it will behave accordingly. Okay, so what I am trying here, I'm saying the id should be an integer, and I am supplying field, and gt equal to 0 means greater than 0. The id value should be greater than 0. This is a rule that I am applying. Okay. Secondly, in the name also, name is a string. Name is of type string. Okay. Name is of type string, and then maximum length should be 10. Okay. And third, this is role. Now this syntax is little different from this syntax annotated one. They both are interchangeably can work, right? They both are similar. I have shown this example because Pydantic shows both example. The best practice is to use the annotated instead of using the directly field approach. Why? Because it shows equal to field, and we start thinking that it has a default value, but it is not that case. Okay, so it is always a good practice to use the annotated approach instead of using the equal to field approach. In case of Pydantic documentation or LangChain or somewhere documentation, you see this kind of usage multiple times. But if you are really building an application for production use, I would request you to use this kind of annotated approach, where you need to pass in the first as a data type and the second as the field. Okay, and multiple metadata can be added here, like multiple arguments within the field can be added here to support it. Okay, so let us see this example. Here I am passing the correct value as per this, so it will not complain. Let me run this. Okay, let me run this program. uv run. We have this program as constraints, src constraint py. So it works. Okay, now let us fail this just to give you an example. Okay, which is now it becomes greater than max length 10. Okay, so it should fail in this case. Now here it fails. Here I am not applied the try catch or try except. That's why this error is coming up like this. Otherwise, in your case, you can apply definitely. But this is how you can add the custom validation. Here instead of GTV, it's also support less than, greater than, equal to, less than, equal to, etc. You can obviously reach out to the documentation and get this thing. Similarly, max length. So if you just, I'm just showing you. So if I show you GT here, right? GE, GT, so all of this it supports. Okay, all of this, there are a lot of things. Pattern it supports, multiple of, REPR, strict mode as well that I was talking about, right? So a lot of these things are supported by this field class, so you can simply make use of it. Okay, so this is about the custom validation or custom rules. Okay, so not exactly I say custom rules, basically the predefined rules within the Pydantic. So let us take you to another example, which is the serialization. Okay, now in Pydantic supports serialization. What does it mean? It says that, okay, whatever schema you define with the help of Pydantic, like this model, in this case we have meeting model. Okay, meeting class, which has three properties basically: when, where, and why, with the data type date time, bytes, and str. Okay, so if we need to convert this model into a JSON, we can do so with the help of Pydantic. Okay, so it supports three type of conversion. It can convert into a dictionary, okay, with the key value pair. It can convert into a dictionary with only JSONable fields, means which the fields which can be converted into JSON string, etc. So only those with the dictionary. Okay, and then third is the JSON. So I've shown this example. So m equal to meeting, this is the object of meeting class. Okay, and then in this object we have multiple function. We have model dump function, and within this model dump function we have special attribute exclude unset, means in this case when and where is set, y is not set. So we want that y should not come as serialized value, right? In the serialized dictionary, the y should not occur because it is not set by our constructor. Okay, secondly, it supports, here explicitly I'm mentioning exclude. What exclude? Exclude this key where. Okay, mode JSON means I want a JSON output. Okay, third is the model dump JSON. By default it will show the JSON output. And the attribute says exclude defaults equal to true. Exclude defaults means whose default values given. So exclude those default attributes. So let me run this program. So you need to remember this model dump JSON, and these are the attribute it support, and this is how we can do the serialization in Pydantic. Okay. So UV run src serialization. Hit enter. Now it shows up the serialized output like this. Okay. Let me show you quickly. So in the first one, when, where, and why is not set, so it does not print out, and then it is a mode JSON, where is excluded, and the third one is like default value is excluded. Okay. So let me clear the screen. So let us understand JSON schema. So you must have heard of OpenAPI, right? Swagger, etc. If you need to generate the Swagger documentation, if suppose you are building a FastAPI, REST API endpoints, etc., and you are making use of Pydantic models, and you want that Pydantic models to generate the JSON schema for OpenAPI documentation, then it is very easy to use Pydantic. Okay, you just have this model example that meeting is a model which makes use of when, where, and why. Where is also making use of the address class, and you need to generate the JSON schema, which is basically in support of OpenAPI 3.1. Basically, whatever the OpenAPI 3.1 standard says that you want that schema to be converted. What you need to do, simply model JSON schema. This function you need to call. Okay, so let me just show you the output of this program. Okay, UV run src / JSON schema.py. Now, if you look into this, the entire schema is in alignment with the OpenAPI documentation. Okay, so with this particular small function, you can make use of this function in the FastAPI, and you can have your REST API documentation ready in a fraction of time. Like, you don't have to set up explicitly. So this is the beauty of Pydantic. Okay, and let's talk about strict mode quickly. So in Pydantic, I told it supports Lex mode and strict mode, Lex mode and strict mode. By default, it is a Lex mode, means it automatically tries to convert things for you. But if you have the strict mode, then it will fail, right? It will not convert. For example, in this case, in this example, let me just clear this one. In this example, we have a meeting class with a base model, a Pydantic base model. Okay, and I'm just here. What I'm trying to do, I'm trying to validate this particular model explicitly. Okay, so in the last, like in case of validation, etc., we are simply supplying the value in constructor, and it start complaining if the value is not correct. Here, what I am doing, I am just trying to check it explicitly, model validate. Okay, just to show that how we can apply the strict mode and Lex mode. Okay, so here, if you look into this, this is a string, this is a date time. In case of Lex mode, it tries to convert this string into date time, and if it gets converted, it will not complain. Okay, so if we run this program, it will not complain. I'm just, for the sake of time, I'm not running the program for this one. So it will run, no problem, no error will come. Okay, but this is the example that I'm going to show. So here in this case, okay, let me just uncomment the model itself. Okay, but here in this case, if you look into that, we are again calling the model validate, but I'm passing the strict equal to true. So in this case, if I'm passing the strict equal to true, it will say that, okay, this is a string and you are asking me to convert to date time, so I will fail because it is a strict mode. Okay, so when this strict mode will be helpful, ideally this is what the go-to approach. We do not have to use the strict mode, but what is the best way of using it? So when you normally make use of model validate JSON, this is a function. Okay, so when is the right time to use the strict mode? When should we use? Okay, let me show you. In this example, like if you look into this, here we are explicitly first validating the JSON data before actually supplying this. Okay, so in the first case, what we are doing, we are simply passing the actual object. Okay, here what we are doing, it says that instead of directly supplying that value to the class, first validate this JSON explicitly. Okay, and if this JSON is validated correctly, then it will give this object. mJSON is basically an object. Okay, and then you can pass this object to the model validate. So in this way, the conversion is automatically done at this point, instead of it tries to convert it automatically. If you do this meeting model validate, it will try to convert itself. But in this case, if you call this model validate JSON explicitly, then it will have an object. And if we pass this object, it will run, because here the conversion already happened. Okay. So this is the best practice. If you go with the strict mode, you first have to convert this JSON object into a normal object and then supply this normal object into the model validate. Now in this case, it will run. There will not be an error. Okay. If I run this program, uv run src slash strict mode, it will run without any error. Okay. Now let's talk about the custom validator, which is the last section or last feature of the Pydantic. Okay, there are a lot of feature in Pydantic in the documentation, but covering this one will cover a lot, so you will have a good understanding of Pydantic and you can make use of it in LangChain and wherever you want to use. Okay, so we are going to see a lot of LangChain videos, upcoming videos, so where we are going to use the Pydantic, so it is easier for you if you follow this video. Now let's understand the custom validator. So in the custom validator, you have heard that, okay, we have seen field, we have applied the predefined rule of greater than, less than, etc. Now, if you have to apply the custom validation, what you need to do? Simply, you just, here in this example, I'm showing you user base model with str. This is what we have already seen. Now, if you want to apply a custom validation where you want to check whether that name has a alphanumeric character or alphabet character only or not. So for that, what you need to do, you need to import the field underscore validator from the Pydantic, right? And then within the class, you need to make use of @field validator and the name of the property. So this should match name, okay? Name of the property and @class method annotation and then function. Okay, this is the custom function which will do the custom validation. The first is CLS, which is the CLS, and second parameter is the value. Okay, value means the value of this name parameter. Now we are doing what? If not value dot is alpha, we are checking whether the value is alphabet or not. If the value is not alphabet, then we are raising an exception explicitly. Value error, name must only contain alphabetic character, and then return the value. Okay, return the value in case if there is no error. Okay, and otherwise we are sending the exception. So this is how you do the custom validation in Pydantic. Okay, and then I'm just calling this function user with the name alice123. If this is not containing any like altogether it is not alphabets, so this error will come. Okay, and then I am catching this error within this except block. So let me run this program quickly. uv run src slash custom validators.py. Now if you look into this completely, this is a validation error, invalid user non-alphabetic name. Okay, and e.errors is printing this error in the array of errors. So that way you can actually introduce the custom validation so within the class. Okay, so we have understood all these pillars of Pydantic: validation, strict mode, serialization, JSON schema, custom validator, constraints, etc. I've pushed this code into the GitHub repo and the link is available in the description. You can check it out, and this is as per latest Pydantic 2.10. So you can apply this code changes directly by picking these pieces from this particular code to your code. Okay, and you will be able to understand the upcoming video if you understand this video very well. The important thing is you just have to use the base model and then start using it. That's it. Okay, so I hope you understand the concept of Pydantic very well in this video. Although I see that this video may become a little lengthy, but I want to make you aware of each of the feature of Pydantic in this crash course so that you do not worry about learning Pydantic again. And yes, you can focus on the AI and Gen AI applications. Thank you so much for watching this video and stay tuned for upcoming videos. Bye.